Welcome back to Best Academic TV. In this video, we're gonna focus on limits of a function by L'Hopital's method. Alright, now whenever you are given a limit and that particular limit occurs to be 0 at numerator, 0 at denominator, we call that limit indeterminate limit. And to evaluate every indeterminate limit, we use L'Hopital's method or factorization method. Please take note. If I'm given limit of f of s over g of s as s tends to a, and when you replace the value of a, we have 0 at numerator, 0 at denominator, we call this particular limit indeterminate limit. Not only that, sometimes you might have the result to be, or you have infinity at numerator, infinity at denominator. We call that particular limit indeterminate limit. And to solve every indeterminate limit when the value of the function of numerator give 0 at numerator and 0 at denominator, we call it indeterminate. Please take note. So if I have a limit that the function gives 0 at numerator and the 0 at numerator and 1 at denominator, we don't call this indeterminate. The answer to this limit is 0. Please take note. But if you are given a limit and you replace the value of s and you have 0 at you have 1 at numerator, 0 at denominator, this is not indeterminate. The answer to this will be infinity, which is undefined. Please take note. Class, please take note of this. If I replace the value of s and I have 0 at numerator, any number, maybe 1 at denominator, the answer to this is 0. And if I replace the value of s and I have 1 at numerator, 0 at denominator, that is not an indeterminate limit. The answer to this is infinity. So if I replace the value of s and it gives, maybe I have 2 over 5, maybe a number at numerator, a number at denominator, that will be the answer to that limit. Please take note. But in any way, if you replace the value of s and you have 0 at numerator, 0 at denominator, that limit will be indeterminate limit. Please take note. Or you replace the value of s and you have infinity at numerator, infinity at denominator, that limit will be indeterminate limit. Most times we always have this particular result for indeterminate limit. Please take note. So let's solve a question here to understand indeterminate limit and how to use L'Hopital's method to solve every indeterminate limit. Okay, let's solve this question here. They said determine limit of s raised to the power of 3 minus 8 over s raised to the power of 2 minus 4 as s tends to 2. Okay, let's solve this question here, class. Okay, for us to know the limit here, for us to know the limit here, the first approach or the first method to use is direct substitution method. Please take note. That means we have to replace the value of s here as 2. When you do that, we have something like this. Okay, when you replace the value of s here, we have something like this: 2 raised to the power of 3 minus 8 divided by 2 raised to the power of 2 minus 4. So this will give us 8 minus 8 over 4 minus 4. And the answer will be 0 here over 0. So class, whenever we replace the value of s and in that limit we have 0 at numerator, 0 at denominator, we call that particular limit indeterminate limit. And the method to evaluate that limit, the method to evaluate every indeterminate limit is by L'Hopital's rule or by factorization method. Okay, let's use the first method here, that is L'Hopital's method. So how do we apply L'Hopital's method? This is what L'Hopital states. It states that if you have two limits, there is limit of f of s over g of s as s tends to a. To evaluate this limit, if the limit is indeterminate, to evaluate the limit will be f prime of s over g prime of s as s tends to a. So what does it mean here? It means that differentiate what is at the top here, you will have this. Differentiate what is at the down here separately, you will have this here. Before you will replace the value of s as what is given to you, okay? So now let's apply this here, class. So I will differentiate this separately and also differentiate this separately before I will replace the value of s. Please take note. So how do we differentiate? Now, whenever I want to differentiate any expression or any function, the first thing is to understand the function. Whenever you are given any equation to differentiate, the first thing is to understand the function. Please take note. Now, the first function we need to know in terms of differentiation is monomial function or polynomial function. Now, when is a function said to be monomial function? Whenever you have an expression like this, class, if I have an expression like this, y is equal to as raised to the power of n. That is, whenever you have one digit, a power, a letter, and a power. One digit, a letter, and a power. We call this monomial function. That means it's having one digit. So how do we differentiate monomial function? We take the power down to the base and subtract 1 from it. That means our dy ds here, our dy over ds will be equal to n dot as raised to the power of n minus 1. So this is how we differentiate all monomial functions. So when we have more than one monomial function, that is any expression or function that is given to you as one digit, a letter, and a power. If you have it to be more than one, how do we differentiate that? We differentiate that 10 by 10, that is 1 by 1. Please take note. But this is what you should understand here, that there's what we call constants in a function. And what is a constant in a function? A constant is any digit that there's no attachment of letter to it. A constant is any digit that there's no attachment of a letter to it. So whenever you want to differentiate any constants, we say that the derivative or the differential coefficient of a constant is equal to 0. So class, let's differentiate this using this format here. We differentiate this here. This is s raised to the power of 3. So there's an invisible digit here, which is 1 here. So take the power down to the base, subtract 1 from it. I will have it to be 2s squared minus. Now class, if you look into this here, class, this is a constant because there's no attachment of letter to it. So when you differentiate this, you have minus 0. That, please remember that the differential coefficient of a constant is equal to 0. Now let's differentiate the denominator here. Now let's differentiate the denominator here. When you differentiate this here, we have 2s minus 0. That is, take the power down to the base, subtract 1 from it. So our result here will be equal to class 2s squared over 2s. So class, the next here is for us to replace the value of s as 2. When you do that, we have something like this. Okay, when we replace the value of s as 2, we have something like this: 2 into 2 squared over 2 into 2. This will be equal to 2 raised to the power of 2 is 4. 4 times 2 is 8 over 2 times 2 is 4. So when you divide it, this will be 2. Please take note of this, okay? So my answer to this here is 2. Okay, let's solve the next one here. That is question 2. Let's solve question 2 here. Class, the first thing to do here is to replace the value of 2. So if is to replace the value of 2. When you replace the value of 2 and the limit of this function here result to be 0 at numerator over 0 at denominator, we call that particular limit indeterminate limit. And for every indeterminate limit, we use two methods to solve. Either use L'Hopital's method or factorization method. Please take note. Okay, all you have to do here is to replace the value of s and comment on the possible method to use to solve this particular limit. Okay, thank you.